In this video, I'll be going through the question you see on the screen here from the 2025 Leaving Cert Ordinary Level Maths Paper 2. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video when you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. The first thing we need to do in question 8 is fill out this table they've given us here. Let me go through what it says. This is every car sold in Ireland in 2023. Total number, all of the car sales was 117,000. This was the number of petrol cars, diesel cars, electric cars and hybrid cars. What they've done then is they've told you the percentage of all cars here, and well, this one is just for a pie chart. We'll deal with that in a minute. Let's just start with the percentage one and then we'll talk again about the pie chart. So what percentage of the total cars is 38,700? They've given you the answer, but I'll show you how to do it. It's 38,700 divided by the total. That's how they got that. And we'll do it 2 times here for the diesel and the hybrid. 25,900 divided by 117,400. That's how we find percentages. You put this into your calculator. I don't have the numbers here, but let's multiply this by 100 to get percentage as well. I get 20, well, let me write it over here. I get 22.06. I don't have the exact numbers. I've already rounded off to 2 decimal places. Apologies for that. Same for hybrid, well, similar for hybrid. 30,300 divided by 117,400. Your calculator will tell you, if you forget to multiply by 100, it's okay. It will tell you 0.19. You can just move the decimals in your head. It'll tell you, oh, I'm sorry, not 19, that's this one here I'm looking at. It'll tell you 25% or 25.81%. That's how you find percentages. You need to be able to do that if we're looking at any data. You want to know, because numbers can be meaningless sometimes. Whereas you put everything into percentages, you know they all add up to 100. You can deal with them. You can deal with them every year. Maybe next year there's half the number of cars sold because of some pandemic. The percentages would still be useful to look at. So percentages are great for that. We're going to do the next part. We're going to draw a pie chart. So for that, they want degrees. How much of a pie chart would petrol fit? They've told us it's 119 degrees. How do they get that? Right, a full circle is 360. 50% of a circle, half a circle is half of that, 360. Half of a circle is 180. How much of a circle do we want for petrol? 32.96%. Half of 360 for 50%. 32.96% of 360. That's what I want for this number. And whether you divide by 100 or you just use the percentage button on your calculator, either way it should give you 119 if you do that. If you multiply 22.06% by 360, you should get 79 degrees here. These are rounded off to the nearest degree. 19.17% or 0.1917 by 360 should give you 69 degrees. All of these should roughly add up to 360, although, yeah, they do actually. Although if they didn't exactly add up, if they were one off, that's probably because of rounding. Okay, let me clean this off so we have room, or I'll fit it in over here. I'll rub this off so we have room to draw the pie chart in the next part. Right, in part 2, they've given us the start of a pie chart. They've put in petrol, they've put in 119 degrees. They want you to put the rest in. You can put them in any order you want really, but I'll just go standard as the list has been and I'll go around this way. Although you could go that way. Diesel I want a pie that is 79 degrees wide. So I take my protractor, put it in the middle, put it along this line, and I find 79 degrees on the, let me draw in a protractor to help you think of it. I put it right here, I go to 79 degrees, I mark it off, and I get my ruler and I draw a line down there. I now know this angle in here is 79 degrees. This is the diesel part. I do the similar thing then for electric. I get 69 degrees on my protractor, I'll draw it, rub this one out, I'll draw it again. Oops. Put my protractor here, I get 69 degrees, mark it off, put a line down. That's probably doesn't look like 69, probably should be more over here. Let's change that. That's electric. I obviously can't do it on the board too well. You should be able to do it much better. Last one, 93 degrees. I don't even have to do it because it's already done. If you're right, I would take my protractor, the same one that's already here, and check, is this 90 degrees, 93 degrees that's marked off. Should be easy to see, it's practically a right angle. If it is off, I don't want you putting in an extra line and having a little sliver where your mistake is. Just go back, start again. This should be all done in pencil, so you can rub it out and start again. It should only take a couple of goes. This last one though is hybrid. Make sure to mark them and put in the degrees, 93 there. Okay, that's it for part A. Let me rub that out and we'll go on to B. In this video, I'll be going through the question you see on the screen here from the 2025 Leaving Cert Ordinary Level Maths Paper 2. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video when you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. Right, in part B, they give us a graph that looks somewhat like this. I don't need to draw it accurately to answer this question. It's a scatter graph. It has loads of dots, probably a little too good, these dots, and more like that. And they ask you about correlation. Specifically, they give you four options. They say, is this strong positive correlation, strong negative, weak positive, and weak negative? So there's two things they're asking there. Is it weak or strong? Is it positive or negative? Let's take them separately. Let me draw a few more scatter graphs. Here's a weak scatter graph. Sorry, there shouldn't be a line there. There's no information there. That's very weak. I don't see anything useful there. And here's one that's really strong. That's already quite strong. That's practically a straight line. A straight line is very strong. Anything looks a little like a straight line is quite strong. This is strong, this is weak. So we can already say this is a strong one. We can see mostly a line. I could very easily draw a line here and you'd go, yeah, I see that. That works. I couldn't draw a line here that you would agree with, that these dots agree with. Of course you could here. So first of all, it's strong. So we can throw out the two weak options. Next, is it positive or negative? Well, here's two examples. This one and this one. One of them's positive, one of them's negative. Positive just means going up. We read from left to right. If it goes up, it's positive. If it goes down, it's negative. This one's clearly going down. So the answer is strong negative is the one you should tick. The reasons are it looks like a straight line. That's what makes it strong. And the reason it's negative is it's going down. So they're the two reasons, the explanation they want. In part 2, it says, Tom says the correlation coefficient of the two sets of data is 5. Explain why this cannot be correct. I don't know if there's a mistake there or it's part of the question, but let me ignore it for a moment. I'll come back, hold on that. The answer, it cannot be correct because the correlation can only be between -1 if it's really good negative. Like this here is probably like minus 0.9. It's really good and it's negative. That's the lowest the number can get. And if it's positive and really good, like this is probably 0.99. It can be between minus 1 and 1. That's the only thing. So 5 is out. That cannot happen. You can't have a correlation that's not between minus 1 and 1. By the way, this correlation of this one here would be about 0. There's nothing there. Maybe 0.001. The bit that confused me is it said 2 sets of data. I read through the question twice there. I don't see where there's 2 sets of data. There's just 1 set of data, I thought. Maybe I'm reading it wrong, or that's part of his mistake. Tom already made 1 mistake. Maybe he's made 2. Okay, let's go on to part C. Okay, part C. Once again, this is actually something really useful in real life. If you're reading news, you can apply what we're going to do in this question to that to tell if how fake the news is. I don't want to say fake news, get myself cancelled here on YouTube, but it can really help what we're going to learn in this part. So they're talking about taking a sample of 815 cars. This is a year after that big sample size we had there. So the next year, that one they looked at all 117,000. It was really good. It looked at everything. This year we're only going to look at a small number, 815. And they first of all ask us to find the margin of error, or they tell us the answer. They tell us it's 3.5%, the margin of error, and find how we got that. This is useful if you ever read a survey done online and they say, oh, we asked 815 people, it will have the same margin of error, roughly. So how do you do it? You can remember it. You can also use your table, maths tables. The answer is in here. Be careful though. It's the statistics section in this is for college students more than anyone. That book's not just for ordinary level. It's for honours and it's for college students. And the stats section gets really weird and interesting. So it might confuse you more than help you. This comes up. You are expected to remember it. The margin of error is 1 divided by the square root of n. N is the population size, the 815 in this case. So the answer here is 1 divided by the square root of 815. Put that into a calculator, you will get 0.035028847. That's what you get out. They've asked you to put the 1 decimal place. Be careful, it's not this one they're talking about. They want you to change the percentage first. 3.5028847 percentage. This is the 1 decimal place. So that's closer to 50 than 60 already, so 0.5%. That's the answer to part 1. Part 2 then, they tell you that 106 out of this 815 new cars were electric cars. Work out the percentage of cars in that sample. So let's see, it was 106 out of 815. It's just divide like that. Put that into your calculator and you will get 0.13006 or 13.006 percentage. To the nearest percent is 13%. Now, part 3 again is something really useful. You will often see people who write articles make grandiose claims about something, and it's often quite wrong. For example, here this reporter said, if you go back to the start of the question, electric cars were selling 19%. Now they're 13%. You will see reporters all the time say, look, it's gone down. 13 is less than 19. Seems to make sense, right? And it will actually make sense in this question. But very often, it's not fair for them to say it. I'll explain more as we go through this. Because this answer of 13% isn't that good. We only looked at a small number. We need to take in the margin of error into account. This 13% we got here is actually better to think of this as 13 minus 3.5 and 13 plus 3.5. The real number, we just call it x, is probably between these two. 13 minus this, that's 9.5%. And this is 16.5%. So how many electric cars are being sold in 2024? From this sample, even though it says 13%, my answer would actually be, you know what, I think it's between 9.5 and 16.5. And it turns out the reporter was correct. So these are your calculations. Your conclusion is the reporter was correct. This number is less than 19. And reason for your conclusion, well, that's it. This number is less than 19. Or 19 is not in this range of answers. And that's it. What you often see reporters do is, let's say it was 19%. Let's say this sample size came out at 16% and plus or minus 3. So the answer is actually 12.5 and 19.5. You'll often see reporters say, oh, it's gone down. 16 is less than 19. Which actually, we can't say that because it's still quite likely to be in this range, although that's quite close to the edge of the range. Anyway, hopefully I didn't confuse you there. Really useful to think of this margin of error. A bigger population means less error. If they had have asked half the cars in the country, or if they checked half the cars in the country, I'd be fairly confident this number would go very close to 0. Whereas if they only asked 2 people going down the road, that's not very useful at all. I probably waffled on a bit too much there. That's it for question 8. If you have any follow-up questions about any of that waffle or anything I did previous, or just point out any mistake I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.